Hi, I'm Susie. Welcome to the first Houdini Kitchen tutorial. Before we get on to learning about specific nodes, I'm going to take a look at how a Houdini scene goes together. For most of these tutorials, I would expect you to follow the tutorial as you go along and create something similar. But for this first one, you should instead open the scene which I've provided alongside the tutorial, called Fairy Hill, and just take a look at it. There's a link at the bottom of this page or in the download section. A lot of this won't make sense yet, but as you move through the tutorials, you can refer back to this scene and see how it's set up. In Houdini, you'll do most of your work inside a single geometry node, but in order to set up the nodes for use in another program, it can be helpful to separate them out into different types of geometry. Or, if you import a scene from outside Houdini, such as an Unreal scene, it will be presented to you as a bunch of separate objects, and it's important to understand what all the different elements mean. So to show you this, I'm going to open the Houdini tree view, something I don't usually use very often, but it's a good way to understand Houdini if you're familiar with other modelling programs or game editors, such as Maya, Max or Unreal. Most elements of a Houdini scene are contained within an object network. This includes geometry, cameras, lights, particles, all the things you'd expect to see in the outliner in Maya. In case you're wondering what the other networks do, at the top of the list we have chops or channel nodes. These are what we would use for manipulating animation or sound. You're unlikely to come across them very often when working with procedural geometry. The IMG network was developed for compositing renders, but it can also be used to manipulate and create textures. We'll be learning more about this because it can allow you to create the kind of procedural texture networks you would expect from Substance Designer. It's a bit harder to learn, but you'll be able to create your own nodes and integrate texture creation with a procedural workflow. Next, we have the Materials Network. This is something that we'll be looking at further into this tutorial series. For now, the most useful thing to know is that the principal shader, which you can see here, is Houdini's real-time PBR shader. Houdini can display all its parameters in the real-time scene view rather than having to render out an image. The Out network is where we create renderers, not just for rendered scenes, but also baking textures from geometry and even baking out geometry. A lot of the time we won't be using these because we'll be creating procedural geometry for generation in another program, but we'll certainly come across them. They're especially useful when batching through a network offline. You'll notice that the network view at the bottom right side of the screen reflects the network which is current. This is where you manipulate the nodes for each network. The shop network or shader operator is the precursor to the material network and is only in Houdini for legacy reasons, so we don't need to worry about it. Finally, the VEX network. Houdini defines this as a container for VOP networks. VEX and VOP are two methods of doing the same thing. Technically, they stand for Vector Operator and Vector Expression Language. These will allow you to manipulate attributes on a per point basis or any other type of component. They use parallel processing, which makes them very fast. Simply put, they'll process all the points at the same time rather than one after the other. VOP is a node-based network similar to the object network, except it runs from left to right rather than top to bottom. You nearly always create these inside a VOP node within your OBJ network. VEX is a programming language that does the same thing. In fact, VOP networks create VEX code, which you can open up and look at and copy. The method you use generally depends on context and your familiarity with either kind. I find I tend to use VOP networks first, but as soon as I need a loop I switch to VEX because it's much easier. We'll be covering both of these in some detail over the course of these tutorials, but don't worry, you don't need to learn the VEX language to use Houdini. So let's go back to the object network, because that's where you'll be working most of the time. We're currently at the top level, where we see our geometry nodes. On the bottom right, you can see a layout of all the top nodes in the object network. The camera and light are pretty self-explanatory. Most of the rest of the nodes you see are currently invisible. You can turn visibility on and off with a little blue tick on the right. To save time, you can do a whole group at the same time. In the scene, each of the boxes now displayed contains one scene element. These geometry nodes are the equivalent of a transform node in the game editor or modeling package. We can use the parameters to move these around in the scene and it doesn't affect the contents. It's what's inside these nodes that makes Houdini so powerful. The simplest node we have in this scene is the grass. It consists of a single SOP file. Unfortunately, this is a bit of Houdini terminology that you need to learn. SOP is a surface operator and refers to the nodes concerned with building geometry, as opposed to particle operators, dynamic operators, shading operators, vector operators, composite operators, render operators, or channel operators. I've put all these acronyms in a cheat sheet on the Houdini Kitchen website so you don't have to remember them. For now, forget the rest and just learn SOPs are the nodes you build geometry networks out of, and VOPs are the subnetworks for manipulating component attributes. Inside the grass geometry, we have a single node which is a file node. If you look at the parameters, you can see it links to an OBJ file, which is provided with the scene. File nodes let you import geometry, such as an OBJ, FBX, or Geo, the Houdini geometry format. In this case, it's a very simple, untextured piece of geometry. Next is a rock geometry. It's created from scratch in Houdini and consists of a very simple network. We create a box, bevel it, and then use a null node to indicate the network's complete. The last node is what's rendered by the geometry node. You can tell because it has the blue display render flag set on. From the geometry level, these two nodes give the same type of result, but the difference is that the rock node is constructed inside Houdini, and we could change the rock parameters at any point along the network. This is what we've done with the ground node. If you select the node, you'll see there are parameters that determine the way it looks. You can raise or lower the hill, make the ditch deeper or shallower. As we change the height, the colour also changes. We can also change the base colour, change how much height influences colour, and we can use roughness to add some unevenness to the surface. If we go inside the ground node, you'll see a longer network, but otherwise something very similar to the rock. This network actually consists of several VOP subnetworks, but I'm not going to go into them right now. Take a look at them yourself and see if you can figure out what they're doing. When you select the nodes, you'll see that some of the parameters are green. This means they're driven from somewhere else. In fact, these are the parameters you were changing on the top node. Green parameters can be toggled between their calculated value and the expression that drives them. It's really easy to drive parameters from another node in Houdini. You just open up the parameter interface, go back and select the node, then drag the name of the parameters from the parameter view into the interface window, and save. Now we could drive the roughness frequency from the geometry node as well. If we were to package up these networks, we could save them as Houdini digital assets and share them between different scenes and any program that's supported by the Houdini engine plugin. Currently these are Maya, Unity and 3D Studio Max, with external support for Cinema 4D. This is how I made the standing stones and trees. If you open up a standing stone, you'll see that there's a single node with some parameters that are specific to standing stones. This node has a little lock symbol, which means it cannot be changed and is referencing a file on the hard drive. You downloaded that HD file along with the Fairy Hill scene. If we open it up, the network inside is greyed out to tell us we cannot edit it. If you wanted to edit it, you would select Allow Editing of Contents, which gives us an unlock symbol. Now we can make our edits. When we're finished editing, we'd select Save Node Type, which updates it on the disk. Then to lock it again, match current definition. If you do this, be careful because it will affect every instance where that HDA file is referenced, even in other scenes. In this scene, any changes will affect all the standing stones. Each of these standing stone instances refers to the same digital asset but has different parameters. Tree nodes are set up in the same way, but in this case it has a single parameter of a random seed, which randomly drives the properties inside the node. This is a nice user-friendly way of creating numerous variations on a theme. So now we have all the building blocks of our scene, we need another network to bring them all together. This is a geometry node that I've called Environment. Even when all the individual parts of the scene are invisible, you'll see them displayed by the Environment node. If we open it up, you can see a more complex network inside. In fact, most of what this is doing is bringing in the separate pieces from the other geometry nodes and laying them out. It's good to get into the habit of storing your geometry in separate nodes because it makes it easier to change it later, and Houdini is all about flexibility. We could have built this entire scene within one geometry node, and to start with, this is probably how you'll work most of the time. But I find that I tend to start working within one geometry node, then when I see what form it's going to take, I start moving pieces out to clean up the scene. To bring in the geometry, we use an object merge node, which simply points to any other part of the scene. You can even grab any piece of a network in another piece of geometry. This demonstrates why it's useful to add a null node called out, which is nothing but a placeholder. It makes it easy to find the last node in the network when you're looking at an alphabetical list. We aren't going to worry too much about what this network does yet. Basically, it brings in the separate pieces of geometry and creates points where we want those pieces to go, and then instances the geometry on top of them. In a Houdini geometry network, only one node can be output, so in order to bring the pieces together we use a merge node. Now if we come out of the environment and select the ground node, but without making it visible, you can see changing the parameters of the ground actually drives the positions of the objects in the scene. One thing to note about this network is that we could have made it a lot simpler by simply driving the parameters on the different trees and standing stones procedurally, rather than setting them up as separate pieces of geometry in advance. I haven't done this because it would mean rebuilding every tree and stone on the fly every time we change the top inputs, and the networks would take a lot longer to build. This way all the calculations are done offline and the tool just chooses between them. That's it for this tutorial. Please ask any questions in the comments and I'll try to answer them. The text for this tutorial is reproduced below in case you want to go back and check anything. In the next tutorial, we're going to go back to the simplest nodes and start to teach you how to build a network from the bottom up.